Okay, we're going to try and do a pretty quick walkthrough of this implicit differentiation worksheet. Okay, first, how do we find y prime? Well, we're going to take the derivative of both sides. Now you may have seen a couple of different notations for doing this. I like to use the Leibniz notation, d by dx. So taking the ordinary derivative of x leads to 4x plus 1 plus, when I see this term, I have x, and then y is to be treated as a function of x. So I have a product of two things here. I need to use the product rule. So how about x times the derivative of y, which we'll write as dy dx, but y prime would be okay as well, plus, leave the y alone, take the derivative of x. Derivative of constant is 0. And now we solve for dy dx. You should be able to check pretty easily that the algebra there, that will work. Okay. Now if we want to do this explicitly, we need to solve our equation above. All right, I'll rewrite it here. For y to get that in terms of x. So we want to get y explicitly as a function of x. So that's y equals 1 minus x minus 2x squared, all divided by x. I'm going to write this as x to the minus 1, so we're breaking this into 3 parts, minus 2x, canceling where possible. And now the derivative, dy dx, or y prime, either one, is going to be minus 1 x to the minus 2 minus 2. All right. Now to show that these two things are equivalent, I'm going to start with this guy and plug my expression. This here is y, so what we're going to do is plug that in right there. All right, and see if we can simplify our first version of the derivative here until we get the second version of the derivative. Okay, so dy dx is minus 1 minus 4x minus y, but I know that y is x to the minus 1 minus 2x, and this is all divided by x. Okay, so this x in the denominator here comes from the x above. I don't know if you could see that all. I may have had the page in the wrong place. But we're starting with dy dx, and we've taken and substituted for y our expression for y from above here. Okay. And now we're going to clean this up. So we get minus 1 over x minus 4x over x minus x to the minus 1 over x. Distribute this minus sign. So plus 1 over x minus 2x over x. These two terms cancel each other. So we have minus 4 minus 1 over x squared. I'm going to take this x to the minus 1 and move it down. Minus 4, and I forgot to distribute the minus. Minus gives me plus 2 equals minus 2 minus 1 over x squared, or negative 2 minus x to the minus 2. Basically, that's exactly the same answer we had when we differentiated explicitly. Okay. So these give us the same form of the derivative. Sorry if I've been a little sloppy tonight. I'm kind of eager to get this done and go to bed. All right. How do we compute y prime here? We're going to take the derivative of both sides. All right, the derivative of y squared. Y is a function of x, so y is our inside function. I have to chain rule here. I get 2 times y times the derivative of the inside, y prime, or dy dx. Take your pick. cosine of xy. Derivative of cosine is minus sine. Leave the inside alone. Now I have to multiply by the derivative of the inside. Derivative of the inside, this is the same term we had on the last page. X times y requires the product rule. X dy dx plus 1 times y. Same thing's going to happen over here when I differentiate the inside. So plus the derivative of e to the xy is e to the xy times the derivative of the inside. The inside here is xy. So again, x dy dx plus 1y. Alright, that's a great first step. If you get that far, you've used the chain rule correctly and you've differentiated y implicitly correctly. The rest of this problem is algebra. The way I like to go here is to get rid of these parentheses by multiplying things through. Get rid of these parentheses by multiplying through. I'll change the y's to y, dy dx's to y primes at this point for simplicity. Going to multiply through here and we get minus sine of xy times y plus e to the xy x y prime plus y e to the xy. Now we're going to gather all the terms with y prime onto one side of the equation. Move everything else to the other side, but it's already there in this case. And then we're going to factor out the y prime on the left and then divide both sides by the number that multiplies y prime to get perfect. So if you got to that, you did good. Alright, this is really a very similar problem, although it looks different. If I rewrote this as y to the fourth equals x plus y cubed, then it's much like the last problem. And this information here is telling me that when x is equal to 1, y is equal to 2, and we want to find y prime. That's what we're looking for. I'm going to go ahead and do this in terms of the original notation, but you could, if you need to, make this translation and then take the derivative of both sides. So we're going to take the derivative of both sides here. Derivative of the inside to the fourth is 4. Leave the inside alone. Cubed times the derivative of the inside. Over here, derivative of some stuff cubed is 3 times that stuff squared times the derivative of the inside. Now let's plug in x equals 1 everywhere. You could, if you want, solve this expression for f prime of x and then plug in x equals 1, but that's a little hard, and we don't have to because all we want here is to plug in the numbers and then solve for f prime. The algebra is equivalent, but simpler once the numbers are in place. F of 1 is 2, so this is 4 times 2 cubed times the thing we're looking for, equals 3 times 1 plus 2 squared times 1 plus f prime of 1, again the thing we're looking for. 4 times 8 is 32 times f prime of 1. 3 times 3 squared is 27 times 1 plus f prime of 1. 32 f prime of 1 minus 27 f prime of 1. So we're distributing this and subtracting it from the left side is equal to 27. 5 f primes of 1 is equal to 27. F prime of 1 is 27/5. Cool. Alright, you have to memorize the derivatives of the 3 major inverse trig functions. First of all, if you haven't watched the videos on inverse trig functions, you better get busy. All right? Or read about them in the book or something. But you need to know that the derivative, for instance, of sine inverse of x, that does not mean the reciprocal of the sine function, is 1 over the square root of 1 minus x squared. If I combine that with the chain rule, the derivative of sine inverse of something is 1 over the square root of 1 minus that something squared times the derivative of that something. Okay. That's what it works here. So y prime is equal to, we're going to use the chain rule. I'm going to take the derivative of sine inverse, leaving what's on the inside alone. So I take the derivative of sine inverse and evaluate it at 2x plus 1, so that gives me 1 over the square root of 1 minus something squared, 2x plus 1 there, times the derivative of the inside, which is simply 2. There's not much simplification you can do here, so let's just leave it about like that. Alright, arc cosine is another way to say cosine inverse, and the derivative of arc cosine is minus 1 over the square root of 1 minus x squared. So here I have to do a product rule. G prime of x, leave the first thing alone, times the derivative of the second, plus take the derivative of the first. That's a chain rule, so I have to multiply by the derivative of the inside, times arc cosine of x. Makes me think of arc reactor and Tony Stark, but what the heck. Alright, so cancel, goes minus 1. Over here if we want, let's see, we can cancel the 2's. We get minus x over the square root of 1 minus x squared. Isn't much left to do with that guy. Alright, finding second derivatives. If you need to, go back and review my video on 3.5. We do an example of this in there. Right? Basically, we have to differentiate twice, but then we get a little clever here and there. So, differentiating once. Right. 3x squared. Here I have to use the chain rule. Y is the inside function, so plus 3y squared times dy dx equals 0. Solving for dy dx here, I'll let you figure out the algebra, gives me minus x squared over y squared. The usual kind of algebra there. Alright, now I'm going to take the derivative of both sides again. So I get d by dx of dy dx. The derivative of the derivative is the second derivative. And on the right side here, I have to do a quotient rule. Or you could move the y squared upstairs and then use a product rule. It doesn't matter. The notation here for the second derivative, we're going to take d times dy, or that's how the notation looks. It's not really multiplication, over dx squared. That's fancy notation for saying y double prime. On the right, we do the quotient rule. So we get y squared times the derivative of minus x squared. So low d high minus high d low. Derivative of low requires a chain rule again, so 2y to the 1 times dy dx over low squared. Right. Now my answer looks funny here. At this point, with implicit derivatives, you should be comfortable having a formula that involves x's and y's, right? But it doesn't usually involve x and y prime. But fortunately, I know that dy dx is given by that expression, so I can take this guy and plug it in. So that's what we're going to do. So I get minus 2xy squared minus minus gives me plus 2x squared y times dy dx, so minus x squared over y squared over y to the fourth. Let's clean up wherever we can here. So one of these y's will cancel, and I'm left with 2. Let's see, a minus, so we'll put the minus here. X to the fourth over y. 1y canceled. Y to the fourth. Okay. I can get a common denominator up here, or I can use this trick. I'm going to multiply the top and the bottom by the same number, and that'll clear out this y. So I get now, distributing that y through, minus 2xy cubed minus 2x to the fourth over y to the fifth power. Right? That is not the answer you would likely see in the back of a textbook. So let's keep going here. I'm going to factor out what I can from the numerator. X cubed was plus y cubed. Well, that looks familiar. Right? At the beginning of this problem, we started with this relationship between x and y. X cubed plus y cubed is equal to 1. So if I use that in my final answer here, x cubed plus y cubed is 1. I can replace this by 1, and I get minus 2x over y to the fifth. Occasionally, when you look at the answers in the back of the book for implicit differentiation, you're not going to get what you expect. All right, maybe you got this far, and you see in the back of the book that there's this answer. When that happens, when there's a kind of a big discrepancy, look to see if somehow they use the original relationship to simplify the result to produce a new, simpler answer. All right, last page. All right, this is just mucking about with the chain rule for a little extra practice. So this is f of g of x. That's what h of x represents. So this doesn't mean multiplication, it's function composition. According to the chain rule, I'm going to differentiate the outside, leave the inside alone, times the derivative of the inside function. So h prime of 1 is f prime at g of 1 times g prime at 1. Okay, let's start on the inside. So g of 1, I go to my graph, g of 1, that's here at a height of 3. So this is f prime at 3 times g prime at 1. The slope here is easy to determine. That's a rise of 3 and a run of 1. So right here we have m is 3. So g prime of 1 I can replace by 3. All right. What about f prime at 3? So I have to look at the graph of f at 3. That'd be about there. So we're going to estimate that the tangent line is something like this. And just for ballpark purposes, let's say that that slope looks like it's about 1. So we'll put an approximation symbol there and say that's about 1. So h prime of 1 is approximately 3. What happens at 0? H prime at 0 is f prime at g of 0 times g prime at 0. Okay, let's get the g of 0 first. G of 0, according to our graph, is 0. So this is f prime at 0 times g prime at 0. So now I need to go to the graph above and get the two slopes at 0. Well, g prime at 0 is 3, just like it was up here. F prime at 0 would be the slope right there. And what is that? Well, maybe it's a little, not quite as steep as -1. So this looks like about a run of 2, and let's just be overly generous here and say that let's see if I do it there. It's a drop of 3 and a run of 1, 2, 3, 4-ish. So let's say that the slope there is -3/4. So this is about -3/4 times 3 equals -9/4. I wouldn't expect a super precise answer there. Right? F prime of 0 we estimated from the graph was -3/4. G prime of 0 we estimated to be 3. Take the product. Right? As long as you have the main idea that f prime is a negative slope in the downward direction, and it's in the ballpark of -1 or -1/2, something like that. G prime of 0, you better get that number right, and it gives you the approximate answer. Does h prime of 2 exist? Nope. Why not? So I need f prime at g of 2 times g prime of 2. Look at your graph. G prime of 2. So at 2, g is non-differentiable. So that derivative does not exist. So the whole derivative can't possibly exist. All right. Thanks for tuning in.